Okay, this is going to be a solve of the PM bracket that happened on Saturday for the last 256 people in Excel. These are the head-to-head knockout rounds, and this case was bigger portals. So this is a follow-on to the portals case, which I'd practiced the day before, which is essentially the same thing. So you start in a grid, you move to a portal. In the old case, it was a singular X. This time we have a 3x3 portal. So I practiced the original case before this with both an indirect approach and a non-indirect approach. And felt pretty confident, and then I absolutely just collapsed and kind of got paralysed on question 4, where you need to determine which portal you're in. So they're labelled 1 to 9, as this picture shows, and I could pull out where the closest portal was and how to get to it like very easily with my lambdas, but I just could not figure out how to determine which area I was in. Now, in hindsight, obviously it's very easy. You would just, copy over the grid like this and paste it, and then you have your answer. So when I get to question 4, I will switch to that approach. So yeah, a bit of a disappointing round for me. I only got 600 points, so I'm still in the competition by the skin of my teeth, and I just had a bad day. I think that's the difference between me and the top guys is when I have a good day, I can be right up there in the top 10, and then when I have a bad day, which is like more than half the time, I just get an average score. So anyway, let's get to it. Bonus 1, if you overlap all of the areas, how many cells would have no portals? So there's a syntax you can do, which I think I've shown before. So you can say equals here and click a cell, and at the minute this will ref out, but if I do something to it, it will show me all the results. So I could H stack it, and then I have the portal in that cell for all areas like here. So what I tried to do is say map all of this stuff, so take it cell by cell, and A1 to T20. Then I wanted to concat, so it would do it cell by cell. However, that doesn't work in this syntax, which is really annoying. So actually what I could have done is remove the map and do it cell by cell. So instead of doing it that way, I could just say concat that, and that actually works. So if I pull that out to T and go down to 20, you will get all of the areas, which is really annoying. I didn't think to just do it cell by cell. I tried to do it in an array, couldn't get anything to work, and just took forever on these two bonuses. But now it's kind of obvious, so I can just do count if this is a blank, and we get 95. 95. And then we also can do the second bonus, so one cell has an overlapping portal. We can see it's this one that has 2 X's, which is G7, so G7. And then these relate to later questions. So I'm going to do kind of a simple method here. So I'm going to say equals indirect of the area with an exclamation mark, A1 to T20, and that, I need an and there, and that is actually going to give me the whole of the area out. So all I need to do is count how many X's are there and divide by 9, essentially. So let's put that back over here. So we can do a count if that says X, and it's weird that count if works on like a spilled array here. I think it's because the indirect formula is giving you a reference as a return instead of the actual cell, so some formulas do that. So anyway, we want to divide that by 9, so that is question 1. Okay, for the next question I'm going to use the same logic, so we just want to know if there's a portal in the area. So let's copy our formula down, and we can say it's this area now, and instead of this A1 to T20, we want the exclamation mark and this cell, like so. So we want to say, instead of count if, we just want to know if it equals X. So instead of count if, we can say if it equals X, give me yes, otherwise give me no. And that is that one done. Okay, next up, take the sum of the rows or columns where there is a portal. So again, let's pull our logic down here, and let's pull our first logic to pull everything. So this is going to be the area. So I'm going to say let A be that, and let's just return A so you can see what I'm doing at each step. So I'm pulling the map, and then I want to know what the row number is everywhere and what the column number is everywhere. And again, in the real thing, I don't know why I do stupid things like this, but I just did R equals row num of this. I could have taken any area, and obviously that doesn't work because I'm not spilling an address. which I don't know why my brain just didn't work to figure this out. I need to actually get the address of the cells. So I have a lambda here that's called address of cells, and obviously you can do this in many other ways. And then if I said row number of that, it would work. So now that I'm on a second go, let's do this properly. It's the row number of the address of those cells. And now you'll see that the row number actually spells out properly. I can do the same for the column number. So C is column of that stuff. And if I spell C, you'll see we get the column numbers. Okay, and let's do a new line, and I can say if this equals row, then I can say if the area is an X, give me the row number, otherwise give me a 0. And then I can say otherwise if A equals X, so then we're looking for the columns, give me the column number, otherwise give me 0. So what that will do is, because we're in the row, it's just going to give me the row numbers of where the portals are. So essentially the next thing I want to do is just take the unique numbers that come up, so the unique rows where there's a portal, and sum them together. So let's just call that end for a second, and we can say to call end. We want the unique of it, and then we want to sum it together. So that should be it. Yeah, that question took me a long while in the live solve as well. Okay, now level 4, this is where I really fell down in the real thing. What I ended up doing is making like an input for the question number and just spilling the map and kind of just looking manually to the cell addresses and what it was. I mean, it only took me like 3 minutes, but I kind of spent about 5 minutes failing. But now let's actually do it properly. So we want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're just going to copy this to all of the places here. And although there's still a little bit of manual work here, it's definitely the quickest way I've found to do it. And then there's one more tricky bit about this question, and that's that they don't tell us which area we're in. The way the question is set up, there's only ever one area that has a portal in that location. So first of all, we need to find out what the area is. Let's just pull what's in area 1. So we can say indirect of 1 and the exclamation mark and this cell address. So that's going to tell us what's in there. So there's nothing. So if we then did that for area 2, 3, 4, and so on, we would go down and get everything. Now weirdly, this syntax does work with map. So if I said map sequence 11, and then I can say lambda A, and what I want to do is do indirect of A, and that. Now I can spill the result across all areas, so I can see that it's 2. So then I can just concatenate that, and that's it. We know what's in there. I just can times by 1 to make the number. Then we know what's in the cell. Okay, so that is that done. We can also do another bonus here. So review your level 4 answers. One number doesn't appear among them. Which is it? Now you can do this one by inspection quite easily, but a nice trick is to say VStack all of your numbers and then all of the things you expect to be there. So sequence of 9. And to find out if anything is missing, you can say unique. And then exactly once. So it's 5 is the missing answer. The reason that works is because when I do the sequence of 9, obviously 5 appears, but because 5 isn't here, when we VStack it together, it appears only once. So we use that unique only once trick to find what's missing. So it's 5. Okay, now level 5, I actually did this one in the real thing because I have a lambda. So I have a closest on map lambda, which I think I've shown off many times now. So the reason I've chosen to do this with an indirect approach instead of a normal approach is because if I was to VStack all of these underneath each other and then spill out what area they're in, when I try to do a closest on map lambda, I am not going to get the correct cell. Whereas when I use indirect, I can use my closest on map lambda basically because the indirect approach is giving me the answer as a reference. That might not make sense, but don't worry too much. So first of all, let's get our map again. So we can say indirect of this is the area, and we want our exclamation mark, and A1 to T20. So that gives us our portal area, now with the numbers spilled out. And then I can say closest on map. So this is our map. The start cell is this. The steps, so we can't move diagonally, so the max steps I could ever do is 40. So I'll just put 40 to see what's within 40 spaces. No diagonals, yes, we cannot move diagonally, so I need to turn that on. And let's just show you what that looks like. So that's going to give me like every cell that has something in it. So this lambda automatically gets rid of blanks. It just tells me what's in the cell address, and how many steps it is away. So this 7 is the answer. This is how far that cell is away. So if there was a specific item there that I was looking for, I could put you know, only 7, and it would tell me where all of the portals beginning with 7 were, or 9, and so on. So I won't use that one. I just want the first row of this. So I'm just going to say index. I could use take as well. 1, 0, and we'll get the first row. So let's drag that down, and these are the answers. The reason I'm spelling the whole row is because there's a bonus to ask like the sum of all of the entrance numbers that you went into. So I'll leave it like that for now. And now we have essentially the same thing. So I'm going to just spill these workings across here and copy it here. So we're going to go to take a portal, and if we go in at number 1, we're going to transport across to the opposite side of the grid. So let's just spill out our sequence 1 to 9, so sequence 3, 3. And then I'm going to put my arrows into a similar table. So if we go in from the top, we're going to go down. The middle is going to be 0. Here we're going to go up. The reason I'm doing this with arrows is because I can use one of my lambdas to move 2 spaces on a map. Let's just censor all this as well. And then it's going to be like this. So everything's kind of going to go to the opposite side with 2 steps. So let's just then do to call this, to call this, and then we have kind of a lookup from numbers to where we're going to go. So we're going to move 3 steps, jump into a portal, and then we're going to move to the opposite side of the portal in the new area. So we're going to look up that. I need to actually look up the number. There we go. And then I can say move on map, so another lambda I've shown off many times. So my start cell is going to be where I entered the portal. My end cell is going to be moving with that arrow with 2 steps. And that is going to tell me that I go to J13. And then the final step is to get the distance from J13 to the target position. So again, I have a lambda for that. Distance from this cell to this cell. Horizontal moves are worth 1, vertical moves are worth 1, and we don't have any diagonal movement or anything allowed. So it's going to be the sum of these 2 numbers. So let's just pull that down. And then we can say equals the sum of this, and that should be our answer. And then question 7 is exactly the same thing. However, when you go in on the corners, you will do these moves, but when you go in on 2, 4, 6 or 8, you stay where you are. So let's just adjust our logic there. So only the diagonals are going to count here, so let's just change it to be like that. And now we can say we're going to move on map, yeah, that's right. And let's just spill this down for a second. What we're going to see is a few errors where we're not picking up an arrow. Or maybe we are. So we go in at F4. I'm saying move, oh, because I'm not looking to the right table. So I need to XLOOKUP into here and return here. So now I think we'll get a few errors where, yeah, we don't have an arrow, we have a 0. So where that's the case, if it's an error here, and then my distance is actually just going to be from the initial portal to the end. So I'm going to say if error, then it's the distance from here to the end. So that should solve it. Oh, and I've just noticed an error. My distance calculation by default is the diagonal distance, so let's turn on only horizontal and vertical. So again, it should just be the sum of, sum of this and this. So yeah, nice and easy with my lambdas, which is so annoying. Like I just can't do this live because as soon as I open it for a second go, I can get through the whole thing in like 15-20 minutes. Anyway, across all games in level 6, how many more or fewer steps would it take if you did not appear on the opposite side of the portal? Okay, so for level 6 and 7, I'm just going to actually copy my answers as values so they don't move, so it doesn't adjust my score. So all I need to do now is, instead of going from the new cell that I moved to, I'm just going to go from my original portal entry cell to the end. Then I can say equals this plus this, so that's my total distance now, and minus off what we had as our original answer. So it's just going to be the sum of all these things, which is 6. So our answer is 6. And the final one, across all levels 5 to 7, what is the total sum of the portal entrance cell numbers? So I already have this set up from the way I did the question, so it's just the sum of these are the entrance cell numbers, these are the entrance cell numbers, and these are the entrance cell numbers. I think, oh, I've missed one. Where's that? Here. I moved this across to align with the next question, so let's just move it back. There we go, and that's a full score. So yeah, this is so frustrating because like this lambda I've had, this is the first real lambda I built. I've used it a lot of times now, and it served me very well. And live, it did question 5 for me, and then anything that was using this 1 to 9 notation, I just couldn't do because I didn't have this set up. So yeah, that really threw me off in this case live. So I need to make sure I have a clear head next weekend, and go into whatever it is ready. Anyway, that's it. So actually this is a fairly easy case, I think, because we've seen a very similar case before. The only new element was this bit, which once you have this little trick, it makes it a lot easier. Anyway, hope you enjoyed, and I will see you next time.